Hi everyone, my name is Jay Mahowski. This is Justin Flynn, Rachel Quavon, Chris Mazinski. Our facilitator is Dr. Deller, who was kind enough to join us today. Our sponsor is Cypress Semiconductor, which is Team 9, and our project is a Zigbee component for PSoC creator. So first I'm going to run through the outline, what we're going to talk about today. A little bit of background on PSoC, what it is, what it stands for, what it's used for, what it's useful for. The software behind it. Then we'll go to the project description. So a little bit about what our project actually is. It's a mesh network using Zigbee protocol, which if none of those terms make sense to you, we'll break everything down as we move forward. Our solution, so what we actually ended up, like what we took into consideration when coming up with a solution to our project. The applications to show off our solution. Both what we proposed and what we finally chose on. And then we'll finish with some project management details such as risk and budget and stuff. So PSoC stands for Programmable System on a Chip. Comes in 3 different flavors, 1, 3, and 5. We're only going to be focusing on 3 and 5 as requested by Cypress for our project. The difference between 3 and 5 is that the architecture is slightly different, and there's more memory in 5, less in 3. 5 uses an ARM Cortex M3 processor that does 100 million instructions per second, while the version 3 has an 8051 processor in it that does 33 million instructions per second. This diagram down here does a great job of representing what the actual PSoC is. In a standard system on chip, when you buy it, what you have is what you get. It's built into the hardware and it has the function that it serves, and that's it. With a PSoC, it's actually programmable, so you can change the functionality as you see fit and upgrade it as necessary. So these little blocks down here that kind of look like Legos, I don't know if you can read them in the back, but there's a pulse width modulator on there, ADC, DAC. There's all different sorts of little pieces there, and you can move them around in the software and configure it however you need to, which is very nice. So here's the development kit that we're using. In the red there, in the box, is the actual PSoC. So you can pull that out simply and place in 1, 3, or 5, whatever module you need. And the development board has got all sorts of nice little toys on it. There's a LCD display up here, serial interface, USB, power, jumpers to set your power output. Around the outside here, you have input output, so Cypress makes extension boards that you can add on, or you can add on your own board if you'd like. And then over here on the proto board, on the development kit here, we have our radio, and that's hooked up to the PSoC along the black strips here. I don't know if you can see those, but that hooks straight into the board there. On the bottom, there's a cap sense, which is like the display on your phone, the capacitive touch display, so they added that for it, which is nice. There's LEDs on there. It's really got a lot of nice tools. There's also, to program it, they give you a little USB stick. You just plug it in your computer, load the program on there, and then you can bring it to the board instead of having the board lugging it around with your computer, and you can easily program it that way. So with that, I'll hand it over to Justin.
I'm Justin Flynn. I'm going to talk about PSoC Creator. PSoC Creator is the software tool that Cypress provides for configuring your PSoCs. Right here, you can see after you interface, you can plug into the kit with the USB cable, and you can actually get a visual representation of the chip itself. So all these pins along the edges correspond to pins on the board. So you can, once you configure them on the right-hand side there, you can drag and drop those so you know which pins in software are working with the pins in the hardware. Right here is the whole workspace for your project, so you can see all the code files that you have to work with. Cypress provides lots of tutorials online, which have been really helpful for us for running through labs to get a feel for how these work. And it's really similar to our last actual 480 lab, where you're writing the code and then you're also making the changes on the board. Here's where things, you actually, through the configuration in this workspace window. On the right-hand side here, you have your component library, which are, you can have digital components, analog components, all your clocks. whichever piece you want to integrate into your design, you click on it, you drag and drop it into the workspace. It's kind of like lab view from there, where you can connect wires to your bins and to other elements that you want to use. You can also double click on the component itself to configure specifics such as frequencies and voltages and things like that on there. And if you want to go to this is where what Cypress actually wants from us is they want us to create one of those components. They want it to be a component that creates a wireless mesh network using the Zigbee protocol, and they also want us to use the XB Digimesh radios, which are pretty common. Actually, some of the other groups use the same radios. They want to make sure that the copyright for the libraries involved are portable between 3 and 5, PSoC 3 and 5. There's some subtle differences like JD mentioned, so we got to make sure that we test both versions to get the same functionality. And then they also requested that we come up with an application demo. So after we set up the libraries and get the components working, come up with some idea where we can actually collect data using the radios and then bring them all together and show that our component actually worked. And with that, I pass it on to Chris for more details.
Cool. So right now we're going to talk about what mesh networks are. So mesh networks are basically a way so that, so if you have a wireless network, right, what do you have? You have a number of nodes and you have some communication links between them. These are kind of like line of sight type things. Maybe you can talk to your friend. You might be able to talk to one of your other friends, but maybe they can't talk to each other because there's some barrier in between them. And basically mesh networking is a way to kind of impose a higher order routing scheme, so that if your friend over here wants to send a message to one of your friends over here, then you can make that possible by ferrying it through an intermediate node. What happens is, if we have some new node join the network, what's going to happen is the mesh network has a protocol that automatically kind of brings some of these new links in. So we have these kind of links that form. And now what happens if we want to route a data packet from this node to this node, we can actually use this node as an intermediate node to ferry data in between the two. And so that's kind of how our mesh network motivating example works. And that's what we're trying to do with our protocol implementation. Now Zigbee is it's a low power wireless, basically a low power wireless ad hoc protocol. The protocol standard is 802.15.4. IEEE standards in this area kind of go with basically a hierarchical numbering system with dots in between them. So 802 stands for this communications range. There's 802.1, 2, 3, 4, 5. These are all kind of broad technical documents that explains how the internet and network communication structures type work. 802.15 is actually personal area networking. So a lot of people know 802.15.1, that's Bluetooth. There's a lot of other security restrictions, a lot of other things in Bluetooth that make it hard to implement on low power devices. So over the last few years, people have developed an alliance and started proposing a new standard called 802.15.4. Now what 802.15.4 is a low layer, it's a MAC layer. So what a MAC layer is, that stands for medium access control. What does medium access control do? That basically means if you have a bunch of people trying to use one physical medium all at the same time, this kind of protocol specifies how they're going to use that base physical layer. So obviously if you have two people speaking in a room really loudly at the same time, you might not be able to hear either one very well. This MAC layer basically says how are you all going to be able to communicate so that everybody can get their message through. On top of that, Zigbee is a little bit higher layer protocol. So typically in computers we have this big TCP/IP infrastructure. We have this low layer MAC stuff that does the routing with CSMA, CSMA star, and all these things. And then on top of that we have these a lot of infrastructure built on top of that. In low power devices we can't really do that because of all the restrictions with just the amount of memory, the amount of processing power on the devices. So instead we replace that whole top part of the routing stack, all of the extra stuff in regular computers, we replaced for these low power devices with this thing called Zigbee, which basically is kind of a lightweight way to exchange data using these things like endpoints, which are basically, if two applications agree to a common number, then they can exchange data, but they can use different endpoints. So if you want to send you know, refrigerator sensor data about temperatures of a refrigerator and have that be kind of distinct from, you know, other kind of maybe a gas measurement, and you want to be able to process those separately, you can use a different endpoint. And it's typically used for home and personal area networks. So we're using these XBee radios. These implement something called XBee Pro DigiMesh 900. What is DigiMesh? Basically this takes Zigbee and on top of that puts a little extra syntax there to establish a little mesh topology. This was kind of the radio suggested by Cypress Semiconductor to use with our project. The way that we interface it is basically just take a UART, which is a standard that's based on RS-232. It's a standard serial communications protocol basically for device interfacing, and that stands for Universal Asynchronous Receive Transmit. It just uses you know, a few different wires, you connect them up. And so Cypress Semiconductor already has a base level component that implements the UART for these PSoC chips. What we do is we take that component, and on top of that, we just build some stuff around that that actually kind of makes a black box layer, so that if somebody wants to take this chip, plug it into our board, they're actually going to be able to use our component, and that's what I'm going to talk about next. So we're going to create a component. We want a schematic component. So what this does is somebody can take our component from our library, they can drag and drop it onto their design, they can stick the chip into their board, and then they can actually use the API that we've written. So the API that stands for Application Programming Interface. Basically somebody plugs the chip in, they make a quick call to XBee Start Radio, and then they have a bunch of calls that our API implements to do things like receive data, you know, attempt to receive data, send 25 characters to address, you know, X. There's some other, just other special things that will be able to basically allow a nice use of our protocol without having to actually understand how it works. So next we have Justin Flynn.
Actually, we have Rachel.
Oh, we have Rachel.
Or me.